and he's going to be stopping in the laboratory later this afternoon.
Wonderful. Okay, we are live streaming on YouTube.
Thank you. Doing just the final checks with Joe and Rich, and then we'll be ready to start. All right. Would like to take the time to thank everybody for joining us today for another presentation of Grease Thief Thursday. This week we'll be talking about our oil filter kit for analysis and getting the most from a failed filter. Today, we'll have Dylan giving us the live demonstration. Dylan's been with MRG Labs for over 2 years. He currently serves as a lubrication chemist, and at MRG, he works in the laboratory analyzing grease and oil samples, participating in R&D projects, and he is ICML certified as LLA1 and MLT1. We also have Rich on today. He'll be making some comments along the way. He's a president at MRG with over 25 years of experience in the development of condition-based maintenance programs. He is ICML certified LLA level 2, MLA level 3, MLT level 2, and MLE certified. And my name is Richard Janoski. I've been with MRG Laboratories for a little bit over 8 years. I currently serve as the laboratory manager. I work here helping to support our analysis of grease and oil samples, whether it be in the laboratory, writing reports, or working with our customers to understand their problems and supporting them through those issues. So why do we want to do filter analysis? Filter performance can have a drastic impact on our asset life. Filters help to remove water, wear, and contamination from the system. Filters also could remove suspended additives. During our analysis, we wanted to look at the filter performance as well as the filter health after it's come out of service. So the first thing we want to do is we want to preserve our critical information if we have an issue with the filter and we would like to do some analysis on that. So the first thing we want to make sure is that there's a set process for handling failures to ensure that none of our data is lost and we can prevent repeat failures in the future by performing our analysis and understanding, was there a mistake that was preventable and is preventable in the future. We want to limit the handling of the filter. We don't want to be having a bunch of people touching it and looking at it with their hands. We want to not clean that filter. We don't want to disassemble it or disturb that. Ideally, we would like to capture that filter in the state that it failed and then get that to the laboratory to provide as much information as possible to them. And that information is going to be with photographs to photograph the issue if it would help tell a good story. We want to document those conditions, so it might be in an email, sending that to the laboratory to document the conditions of what was observed or what happened right before the filter failure. And if anything was disturbed to perform the filter removal or change out, we would want to note that. That way damage would not be noted as an issue and it would be understood that it happened during the removal of the filter. So our sample collection, now that we've got the filter, we want to preserve that sample, as we mentioned, for the laboratory so that they're able to perform analysis on as many the oil as well as the filter. So you should have a heavy duty bag and or an overpack that would be able to hold the filter and retain that oil for testing without contaminating it while it's being shipped to the laboratory. A good practice would be to collect an oil sample upstream and downstream of the filter, as well as a sample of the new oil, and submit all of that for analysis. And that's going to allow us to see what was being used in the asset, and then look at the oil upstream and downstream of the filter, and that's going to give us an idea of how the filter was performing. And all of that filter and the oil samples can be shipped to prevent damage. And like we mentioned, that we have an overpack. And then when we get later in the presentation, you'll see the filter analysis kit that we have, and that's going to protect our filter and the samples as they get returned to the laboratory. Then we have our filter analysis. So as we mentioned, we have our oil samples, and we're going to perform our traditional oil analysis on the samples. We're going to look for our telltale signs of any issues in our wear, our contamination. Is there any viscosity issues? Are there any antioxidant or other additive issues? And then we're also going to be able to do an analysis of the filter. So the first thing we're going to want to do is flush the filter with a blank oil, and that's going to allow us to push any particles off of the filter and be able to analyze the particles that are being trapped on the filter. And then after we do a blank oil flush, we'll also do a flush with a solvent, and that's going to allow us to compare the particles that are captured in the oil and the particles that are captured in the solvent. And we're able to see, are there any soluble particles possibly being trapped on the filter, for example, by doing one with oil and one with solvent. And that analysis is put into the report. And the next thing that we would look at then is the filter media. So there we can see in the picture, we're inspecting the filter media, looking for any signs of damage or any issues or any obvious abnormalities that are on the filter the whole way around. And then after we do the physical inspection with our eyes, we would also want to remove sections of the filter, and we're going to put that under the microscope to make sure that we can look for any signs that we're obviously not going to be able to see with our eye. So while we're talking about this, we just want to mention some failure site safety. So while working around a failure, we want to ensure that the safety and awareness of all the personnel at the site is high. Everybody understands any kind of dangers or issues that could be present due to the failure. For example, clogged filters can lead to a buildup of pressure. So we would want to make sure that we're not getting into any dangerous situations with pressure. We want to ensure that the equipment is powered off before starting any evidence collection. We would not want any accidents because of an accidental powering on of the equipment. Then next, we would assess the equipment for any dangerous mechanical conditions. So due to the failure, has something changed that would inherently make it unsafe now to reach in? And do we need to fix that first before we would retrieve the filter, bearing, or other piece of equipment that we would want to inspect after a failure? And lastly, we would want to clean up any of the hazardous spills, and then we would want to place cones to alert personnel walking through the site. We would definitely not want any slips or any issues with anything that might have been spilled from the equipment. So we just always want to remember and remind that safety is always first. So next here we can see the filter kit. So later during the live demonstration, Dylan's going to show and talk about how this filter kit would be used. But we can see there in the picture, there are heavy duty bags that would be able to hold a filter inside of them and then be able to put inside the overpack. Other parts could also be able to be put inside of those large heavy duty bags. Inside the box, there is a cap for spin-on filters, and you'd be able to seal a spin-on filter with that cap. There are sealed air Instapacks to be able to properly pack the filter during shipping, and we'd be able to prevent any movement while the filter and the samples are in the case, and it would not disturb them during the shipping transportation process. There are oil sampling bottles inside of there. There's 2 regular oil sampling bottles if you have traditional ports to use or a vampire pump to use. There's also 2 ultra clean vacuum bottles inside that are under vacuum, and there's tubing in the kit, and you would be able to put the tubing on top of the bottle following the instructions that are inside the kit. There's an instruction card inside there for taking that oil sample, and you'd be able to put the tube inside or in the reservoir or upside or downside of the filter stream and take those samples of your oil. And then also we can see there the bright orange durable and waterproof traveling case, and that's what's going to keep our overpack and our samples safe while they're in shipping.
Yeah, Richard, there's different size filters, both canister type filters and spin-on type filters. Can you address what the standard kit would accommodate, and how someone would identify that if they have a non-standard size filter, how the kit might be modified for that?
I believe that the standard that we're seeing there in the picture is a 4-inch outer diameter uh, overpack, but we have the ability to make varying sizes. So we have in-house from 2 inches up to 6 inches. But if we did have a customer that had a custom filter that was a specific size, we would be able to accommodate. We could always get a larger travel case and a larger overpack. And we could always accommodate for a customer that needed to get a larger filter shipped safely.
So then the kit will tell what the maximum size canister filter that could be accommodated by it, and then the customer would have to identify they have something different, and then we could customize to that.
Yep. Whenever they would go to get that kit, we would make sure that the size is appropriate for what they have in house. And then if the standard 4 inches would not work, yep, we could go larger or we could go smaller based on their needs. Yep.
And can you talk a little bit about the importance and what led to the development of this kit? In other words, how filters have showed up in the past, and how any compromise or damage in shipment kind of maybe hides from the analysis what we can really tell them about what happened to their filter in service. So really what's behind this extra effort to protect the filter in transit.
Yeah, definitely. I can think of a couple examples. The first one, as you kind of mentioned, was the filter that was damaged in shipping to the laboratory. So if the filter is not inside of an overpack or a durable container, the filter was inside of a plastic bag, which was great for the beginning part of the process, but then they put it just inside of a cardboard box that was roughly the same size. During traveling, it got another box dropped on it, and then that damaged the area that they had actually sent us a picture wanting to look for us to investigate. So that made it a little bit harder to investigate in that situation. I can also think of situations in shipping where the container was not tight and all the oil that was in the filter was able to leak out. And then we got a dirty, oily box that had soaked up all the oil from the filter. And then we had the filter with no oil in it. So we were able to do the physical inspection of the filter, but we weren't able to analyze any oil itself. And then there's also the case of we had a customer, they were waiting to ship, and then somebody else came along and they threw away the filter. And so that's also a benefit of having a kit like this, is that you have something there that's ready to go. It's part of the procedure that we talked about for how we address filter failures or just any failure in general. And if you have this kit, you're able to grab the kit, get the filter, put everything inside of it, and then you can ship it right out that day. Versus if you have to grab something, put it on a desk, somebody looks at it for a couple of days and they go, okay, we don't need this dirty filter sitting here anymore. Let's get rid of it.
Yeah, so it's really just about adding kind of another level of the chain of custody, really. And we can almost think of it like evidence, how evidence is treated at a crime scene. And so this kit is an effort to create a real process around this. Because unfortunately, too many companies, they just, hey, did anybody grab that filter? Where is that filter? It's sitting around. It certainly looks like trash and historically has been trash. And without an extra effort, may very well end up in the trash. And so, yeah, sure, this is a great way of trying to preserve that evidence the best we can to get a really good analysis for the effort that's going into it.
So as we mentioned earlier, we're going to talk about how to use that filter kit. So we talked earlier, we don't want to clean anything. We want to put the filter into our overpack. We want to obtain our oil samples from the in-service and unused oil. We want to place our samples in our overpack back inside of our filter kit and then ship out to the laboratory for analysis. So it's nice and simple. These instructions are inside the kit too to be able to help. So no pressure in having to remember it, down the road when you need the kit, but you have that kit ready when you do need it. A big thing, we talked a little bit about it before, but it's just the information preservation. So we wanted to stress these points again. The information preservation is essential for the lab investigation to put together the cause of the failure. If the parts are cleaned, we're not going to get all the information that we need to be able to put together that high value report for your effort that you're going through to collect the filter or collect the failed component. So as we mentioned, we don't want to clean those parts. We're going to wash off evidence, as Rich mentioned, and we're going to get rid of that evidence. And then without that evidence, it makes the job of the investigators much, much harder. Third one's a very important one. We don't want to impact, pick at, or rub the filter surface. So we mentioned this earlier. If you do damage the filter while you're removing it due to the situation, you would want to note that for the laboratory so they understand that, because otherwise that it could be taken as an issue that the filter was going through, and then the laboratory is looking at something that didn't actually happen. And then the packaging securely and to seal those components. So getting that filter inside of our tube, making sure that the oil stays in there, it's not going to be able to get lost, and then it'll be preserved for the laboratory for analysis. So corrective action plans. So we want to identify similar filter failures. So filters we can look at by types and the type of service that they're going at. And if we want to gain value from the filter analysis, ideally we would find out the cause of our failure, and then we would be able to take corrective action, and we can apply across the plant or across the company, the organization, whatever, to make sure that we have controls in place to prevent a similar filter failure from repeating in the organization. We would like to look at our task prioritization and the assignment. So we want to understand the difference between our short-term and our long-term plans. And we want to make sure that the assignment of our tasks, resources, and the schedule makes sense towards those plans. So looking at, our highest, what's our most important asset, for example, might be in our short term, and then long term might include some other things that aren't as high value or imminent to the operation of the organization. And then monitoring the performance indicators. So after you get a filter failure or an RCFA analysis, making sure that you're evaluating the report and then following through on the corrective actions that are on that report, that you can enhance your program to prevent those repeat or similar failures. So next, we've got a couple of case studies of filter analysis that we're going to talk through, and then we'll get into our live demonstration. So our first case study is from a G&L boring mill hydraulic system. The system had to have a changeover of oil. The system had a severely decreased filter life after the oil change. Due to this, the system was thoroughly cleaned with industrial solvent cleaner before the introduction of the new oil. So they thought they were doing the right thing, getting everything ready and cleaned. And then we get to our findings. So the filter contained a much lower amount of particulate than expected. The oil did not show contamination or high wear. So that was also kind of surprising in our analysis. But the filter was physically deteriorated and far beyond what would be expected at its end of life. And there we can kind of see in that filter picture that we do not want that if we have a choice. So our conclusion is that the leftover solvent, this leftover solvent cleaner was dissolving the filter resin, and then it redistributed that resin in the filter. So this redistributed resin caused blockages in the filter, and then that was what was causing the filter failure. So on the left, we can see a picture of the normal filter, and it's in its undamaged state. And then on the right there, we can see where that redistribution of resin has moved, and the filter media just looks much more different. And we can see that it doesn't have the same opacity seen through it.
Yeah, Richard, and I was called in on this one because this particular customer was really baffled by a filter system where shortly after they would install a brand new filter, it would go right out on DP. They couldn't get any flow through the filter, and we saw this effect and didn't know what quite to make of it until I got on site and talked to the mechanic who was in charge of changing out the filters, and he communicated that he was using brake cleaner and spraying the inside of the filter housing to help clean it out. But it was the brake cleaner, the very aggressive solvent that was dissolving the resin, the little tiny bit of resin that coats the fibers in a glass fiber filter, that just dissolved it, redistributed it, and completely blocked up all the pores, as you see on the right. So really interesting one, and the root cause on that failure helped us identify a poor maintenance practice, which was completely interfering with the functionality of their filtration systems.
So our next is a varnish removal system from a paper mill. The system has two different oils that are used. It's an ISO 220 mineral oil and an ISO 150 PAO oil. And they were having an issue with filter clogging. And the picture on the right there is the filter after it was removed from the housing. The housing almost was like a large bucket. You can see the lid there behind it, the bright green lid. The oil in the filter had a viscosity that was much higher than expected compared to the oil. So we kind of mentioned that earlier. We had the sample from our customer of the oil that was being put in, and the viscosity of the oil that we got out of the filter was much, much higher than what was to be used. The filter medium was in good condition when we inspected it. We didn't show any heavy amounts of particulate. And the root cause ended up being the incompatibility between the two oils, and that likely caused an issue with the additive package. And then that was changing the viscosity of the oil while it was in service. And just to show that, on the left there, we show the new filter medium, and on the right, there's the used filter medium. So in the last picture, there was a drastic change, where here, there's not a large change in how the filter medium looks in this case study. And then on to our third case study. This was from a helicopter hydraulic system. The system was experiencing high differential pressure issues, and it utilized two different filters, one on the pressure side and one on the return side of the system. Some of our findings from the study: the filter media itself was in good condition, but we were seeing a large amount of metal particles that were present. Some of them were several hundred microns long, and there was a high amount of abrasive wear particulate. So we talked about that before in our analytical ferrography Grease Thief Thursdays. And we know that our abrasive wear or cutting wear could be referred to sometimes as our two-body or three-body wear. But that abrasive wear is just showing that there was some issues inside of our equipment, and we were getting that metal-to-metal contact.
Yeah, I think, Richard, you'd call these two-body wear particles.
Yes.
Yeah, and I think it was interesting in this case is that, often you're opening a filter and you're expecting to see the filter removing what it's supposed to remove, which is, dirt, basically dirt, sand, other extraneous contaminants. Very little of that was seen here. In other words, the oil was kind of clean, but the wear metal was just phenomenal. The size, the amount that was there really pointed towards a mechanical problem with that machine. And the only symptom they were getting at that point was filter high DP. But instead of the filter high DP being a sign of just dirty oil or dirt getting into the oil, it was actually a wear problem.
Yes. And so our conclusions from that case study: there's that it's good to talk it through though. The filters were full of particulate, and that was causing the system to go into bypass. And the back force from the bypass procedure created the high differential pressure that Rich was talking about, and then that was causing the filters to get a blowout condition, and then that was making them definitely of no help for anybody. The investigation of the source of the abrasive particles in the lubricant was needed, and we were able to help them identify using SEM EDAX. We were able to help them identify the metallurgy of those particles, and then after that issue, periodic oil analysis was able to help them monitor those wear levels to make sure that they had addressed their issue with that component.
Yeah, and if I could talk about bypass for a minute, we often think of bypass being kind of a automatic function where there's a pressure relief maybe built into the filter or built into the housing, maybe the head of the filter housing, such that when the filter gets clogged, the pressure causes that to lift and go into bypass. That's not what it was here. There was a manual bypass valve that allowed them to bypass the filter. And by utilizing that in response to a DP alarm, they were actually creating a kind of a backwards flow condition that pressurized the filter in a reverse direction, caused the filter to bulge out. So they were damaging the filter with their little manual bypass process. And that was another significant kind of operational finding. More than anything, basically the customer was able to find out things about abnormal operation of the system by looking at the filter analysis. So, we think about what's filter analysis for. It's to find the dirt particles that the filter picked up. Yes, it can do that. It can also pick up abnormal wear conditions. It can compress the timeline, and look at things that may not be in the oil sample today, but did show up. In fact, this morning earlier, I was in a conference in Germany remotely, and Mark Redding of Poseidon was talking there about when they use the online sensors in wind turbine gearboxes, they're able to see how the wear rates are, and they're very much variable. There'll be a period of operation where there's very little wear being generated. Then suddenly the operational conditions will change, the loading conditions will change. In that case, the wind will change, and then there'll be a short period of high wear rate generation. And so this is one of the potential blind spots for oil analysis, that if the wear gets a chance to settle out or be filtered out before we come along to take the sample, we may miss out on that. Whereas the filter is capturing a percentage of this wear all of that time. So it does compress that timeline, allow us to catch these intermittent conditions that could lead to high wear, significant wear, that sort of thing. Heck, we may find out that in these filters, in this case study number 3, the wear condition was being created when that manual bypass was taking place and no other time. So these intermittent issues can be captured in the filter and can be very complementary to oil analysis. So just want to talk about all the different things that we can get out of this filter analysis, including intermittent things, operational conditions, and even problems with the installation of the filter and things like that. So that was really good, Richard. It's very helpful and a nice overview. And now I think you have a opportunity to do a live demo for us.
Yep. I'm going to stop sharing my screen, and then Dylan will be able to share his camera, and then we will be able to give a demonstration of the kit.
All right. So I wanted to do a short demonstration just to show you kind of what's in the filter kit and kind of a generic example of why it's so important. So this is the filter. This is a kind of a generic sized filter kit right here. So I'm just going to open it up here and we'll see what's inside of it. So inside, if the webcam will focus. Go ahead, Rich.
It's there, so
Yeah, it's I think it's taking a second to focus. But inside we have this tube, this overpack here. If you can see that. It's gone for a second. We can open that and hold on. Try to fix the webcam here. There we go. I think that's better. There's just a little bit of lighting here, but try not to shake the table. I think the table threw it off. But anyway, so we have our overpack here, which is this tube. And these tubes, we do have different sizes available. This is kind of just an average size one to hold a filter of an outside diameter of 4 inches or less. We can also make tubes that accommodate larger ones. This would be more for like a canister filter. We have that. I'm going to set it over here to not rock the table. So inside the kit also, we have this our box, kind of an oil analysis type kit. We do have these 3 sealed air Instapacks to help with shipping filter, but then we also have our vacuum oil bottles and our regular high temperature oil bottles too. This is for oil sampling because, as was mentioned earlier, we want to take oil samples as well with filter analysis because it gives us an idea of the condition of the oil before and after filtering. So these are also important. Inside we also have some labels here that you can use to kind of, you put on your bottles. And then on the outside, we have a QR code with instructions on how to use the kit, how to use the sealed air Instapacks as well. And then here we have a head for a spin-on filter. And this is here, hold on, sorry. This here is used for when you have a spin-on filter, kind of like what goes on a car. And basically what this does is able to screw onto the filter like this to secure it so there's no contamination or no loss of oil during shipping. So ordinarily, right, this filter would be taken off of something, off of a hydraulic system or a vehicle or anything, right? And then rather than just kind of throwing it in a box or throwing it in a bag and shipping it where it's going to tilt and all kinds of things, oil's going to come out. Rather than have that and kind of have the analysis ruined because the oil is no longer in there, we can screw this cap on and it'll screw on like this and it'll seal, it'll mate to the seal on the filter. And there are also different sizes of these heads available too because there are different size spin-on filters out there too, right? So we can make this that seal, and then if there was oil in there, it would not be coming out because it's now sealed in this head. The advantages of the head are also kind of twofold. It's also an advantage for the laboratory too because see this head has 2 different caps on it, right? So when this gets back to the laboratory, we're able to screw off one end like that, and we can pour out the oil that was still in the filter but was just filtered on the other side of the filter media, and then we can unscrew this side and we can pour off the oil that was in the filter but didn't actually pass through the filter media yet. And we're able to do that because of the separate compartments in this head, which might be kind of hard to see. But this part here, if you can see, is sealed off from the middle. So we have our center part where the oil is coming in sealed separately from the part where the oil is coming out of the filter. So that also helps not only in shipping to prevent contamination, but also helps the laboratory with analysis.
And just for clarity there, Dylan, the the center would be the oil as it exits the filter, and the small
Oh, yes.
holes would be the inlet. So we can look at them selectively, like we can pour one out into one bottle, one out into the other bottle, and actually be backwashing a little bit of the filter that was on the upstream side.
Yes, correct. Sorry, I misspoke. There is a thing on here that says flow. It tells you where the oil is coming out of the center and into that. But yes, and then yeah, I just wanted to show that, and then I kind of wanted to show also kind of what the inside of the filter looks like after it comes back. So we would get this filter into the lab. We would pour the oil off like normal, and then also we would want to inspect the inside of the filter too to see what it looks like. So we have our custom-made filter cutter here, which we can adjust for size. And what happens is the filter will be placed in there like this, and then the filter we can spin the filter around on these rollers here, and we can cut it. So I have a filter that's already cut here that I just wanted to show. And okay, the webcam is still good. So here we have this filter here that was already cut. So you see the top part was cut off there, and inside we have the filter media. So this would be inspected too with FTIR and with microscopic analysis, kind of looking at the condition of the filter media like we had talked about. And with our photoacoustic FTIR, we can kind of see what's present on the filter media itself. So I just wanted to show that as well. That's pretty much all I have for my live demonstration here.
Thank you very much, Dylan, for giving us that demonstration of the kit and explaining how those different parts work. And I'll just open it up now. If there's any questions, we can look for that in the chat and we'll be able to answer those. If there aren't any questions, I would just like to thank everybody for joining us today for Grease Thief Thursday. It's been a different year, 2021, but we've really enjoyed being able to share our excitement about the different things that we're doing and sharing, the neat things that we're able to do at the lab. Just want to remind or share with everybody that next month, we are not going to be doing a Grease Thief Thursday in December, but we will be back in January to start up for 2022 for Grease Thief Thursday.
Richard, I'm going to ask you to pull up a generic report so you can show what that looks like. And while you're looking for that and bringing that up on screen, I'm going to answer a question or bring up a question that was asked by Mindy Villalba. And she asks, are these kits reusable? And so I know, Dylan, we've talked about, there's some aspects of the kit that are definitely being consumed, right? The expansion foam packs, they're once and done. And certainly any of the bags that are used to go around the filter and keep from leaking. But I think we've got a number of reusable components in this kit, right?
Yes.
Yes, we do have a number of reusable parts in the kit. So the case obviously is reusable. The oil bottles are not, but the spin-on head and the tube to pack the filter in can be cleaned with solvent and reused between filters. So those two there, yes, you could continue to use over and over again. And if you have one, you'd have one that's sized for whatever you need if you have something weird. And then, yeah, you can keep reusing the parts of the kit.
And that would certainly be practical. And, we've talked about that. So we have similar kits for bearing analysis, root cause failure analysis for bearings. And it's the same sort of thing where the kit comes back, the component is recovered, and the analysis is done. And then the next step is to rebuild the kit, is to identify the aspects that were consumed, cannot be reused, clean the ones that can, and then restock the kit and have it ready to go again. So thank you, Mindy, for that question. Yeah. So Richard, you got an example up for us.
Yep. So this is the first case study we have the demo report for. So obviously 3 slides isn't a lot of information to see. So we'll go down through here and show some of the different stuff that we did. So at the beginning, we just talked about, this is on the slide, but we have our purpose for the failure analysis, the methodology, covering the different analysis we did. So here you heard Dylan mention there's FTIR analysis. We're doing our RDE analysis for elemental levels, microscopic analysis to characterize particles, as well as looking at the filter itself. And all these results are put into our report. So then next here we get into our findings. So that has a talking about the decreased filter life, likely due to the interaction of the chemicals in the system, such as the cleaner or solvent. Going down though, looking at the physical results, here we have our particle count with our ISO codes for the different samples that were pulled. So here we can see that there was a storage tank, the baseline sample, and then 2 transfer samples and 2 different reservoir samples. So that kind of just lets us see what the cleanliness of the oil looks like in the different areas that the samples were taken. And obviously everybody understands the importance of oil cleanliness. Next, we have our FTIR analysis. So here we can see that the spectra is overlaid and we're seeing a good match or a good confirmation of the 2 spectra. We're not seeing any unique peaks or anything like that. So we know that there wasn't any kind of contamination or change in the oil while it was in service. And then we've got that picture that we saw on the PowerPoint there, where we had the filter was falling apart due to that solvent that was getting on the fibers and causing the resin to be able to move and then reposition itself elsewhere in the filter to clog. Another FTIR spectra. This one is comparing the filter element and the base oil just to see if there's any differences or unique peaks that were unique to the filter element. We have our elemental concentrations, talking about the, and specifically in this one, the high silicon, and then the change in the phosphorus to zinc ratio, indicating that there was a issue with the additives that were being trapped in the fibers. And then,
yeah, and really that zinc phosphorus additive is a dissolved additive, which would normally go right through the filter. And when you're seeing it show up on the filter itself, it gives you an indication that some of that additive has been depleted, come out of solution, and is being captured, which is a part of its mechanism, part of its operational mechanism.
Yep. Here's the pictures we showed. So the top picture is the deteriorated filter where the resin has been able to move and is now causing the blockage of the filter, forcing the premature failure. And then here, just some more images that weren't as telltale or nice. We didn't want to make too many slides in the PowerPoint earlier. And then down here, we've got, this is a picture of the debris that's in the bottle, the bottom of the bottle. So just noting that, we always want to put all the data, all the information into the report for the customer. And then here are some of the debris pictures that we found in the block. So this is kind of just showing the consistent dirt particles that were found around where the filter was.
Yeah, and you take, oh goodness, right, I remember that.
Yeah, and that's the solvent, and then you can see in the bottom on the right side of the picture that the solvent ate the plastic bottle.
Yeah, this kind of got me to the root cause, because I was sitting there and the guy said, yeah, I cleaned it out with this brake cleaner. I said, could you just spray some of that into my sample bottle? I want to take it back and see if it could potentially be responsible for the problems with your filter, and it melted the bottom. bottom of the bottle. So obviously a very aggressive solvent that went on and attacked the resins in that particular filter. And I think the thing here to realize, and we've got the root causes and the contributing causes, which is great. What the findings are, and this was from quite some time ago. Dylan and I recently visited that same facility, talked to the folks there about having been involved in this issue. And up to that time, this was a chronically problematic system for that facility. And as a result of making these changes and finding what the root cause of their issues were, it has been running trouble-free for the last few years. So you really take the value in something like this and multiply it out to take a chronically problem system with multiple shutdowns and interruptions to production, and you completely eliminate these recurring issues by getting to the root of the problem. And so that's what we successfully did here. So that's great. Richard, thank you so much for pulling that up and adding that to, as an element to this. And so I'd like to thank Richard and Dylan for putting this together here today. I think it was very nicely done. Really lays out for folks what our service, our filter root cause analysis service can really do and what it can find for folks, and just shows that value. And if you've got interest in that, please reach out to us. Contact us in the laboratory. mrgcorp.com is our website. You can call us here in the lab and tell us what your issue is or what your challenge is, and we can get you set up with these kits. I think it's a good idea to keep some kits on site, and then when the issue comes up, because you never know when you're going to have a sudden DP issue or you're going to have to change it out. If the kits are there ready to deploy, they can be grabbed, they can be taken to the field, saving all this evidence for a really thorough analysis. And so that would be my recommendation to anyone who has critical assets that are protected with filters that could possibly use this kind of service. Richard, you were kind of wrapping us up, telling us, I think, that we're finishing out 2021 now, and we're looking ahead into 2022 for the next Grease Thief Thursday.
Yes, that is correct. We are not doing one in December. Sorry, lost my train of thought there for a second. Taking the time as a team to celebrate the end of the year, and we will be back in January to start fresh and with some new ideas.
Great. Well, thank you, and thanks for everyone that participated. Again, this will be saved online with YouTube, and we'll send out the link to that as well. Everybody have a good rest of the year. We look forward to seeing you again in 2022, holding again our Grease Thief Thursdays with new and interesting topics. And if you have topics for us you'd like to see covered, reach out to us, let us know what they are, and we'll look for them in 2022. Thank you very much.